Imagine a self-hosted agent that can read your messages, run shell commands, and move real money. It's either your biggest productivity win or a one-click compromise waiting to happen. OpenClaw sits exactly on that knife edge. Welcome back to Inference and Insight. I'm Ray. Today's subject is OpenClaw, and here's the uncomfortable truth. If you deploy it like a normal chat assistant, you're already behind. OpenClaw is automation software wearing a chat interface. Credentials plus integrations plus code execution. That's why it's powerful, and why it drew serious security heat in early 2026. Signal scan. What is OpenClaw? Confirmed in docs and reporting. It's open source and self-hostable, positioned as a personal agent. You message it where you already work, often team chat, and it can take actions through integrations called skills. A gateway component bridges connectors and routes events into an agent runtime. So it's not just answering, it's executing workflows. What can teams do with it today? Centralize inbound requests from chat, normalize them, and convert them into controlled tool calls. Schedule work, file tickets, pull data through model context protocol. Basically, a standard way to let a model query approved tools and data sources, summarize incidents, update docs, and run light operations automations. The big differentiator is chat as the command surface, paired with an extensible skill model and a persistent process that keeps state across sessions. Here's the trade-off that frames everything else. Every connector is a new, untrusted input surface, and every skill is more executable surface. Treat OpenClaw like a high-privilege automation runtime, not a friendly assistant. If it can touch your file system, make network calls, and use tokens, it deserves the same controls you'd put on a remote admin tool. Transition, and now a deep dive on how it works, because the implementation details change your security posture. A user message lands in chat. A connector receives it and forwards it to the gateway. The gateway normalizes the event, routes it into a session namespace, and the agent core assembles context. System directives, prior transcripts, memory files, and skill instructions. Then it calls your chosen language model using your own key and interprets the response into tool invocations. One confirmed detail that matters. Skills are loaded from the file system with a precedence order. Bundled skills, then a local managed directory under your home folder, then a workspace skills directory that can override on conflict. Practical implication. If someone can write to those directories, they can add behavior or shadow existing behavior. That's customization by design, and a predictable attack target. The runtime model is the other mental shift. OpenClaw runs as a persistent process, closer to a background daemon than a browser toy. It keeps file-based memory, like JSON lines transcripts, JSON lines, one record per line, and markdown state. It often uses a reasoning and acting loop, sometimes called react, where the model proposes tool calls and the system executes them. It also uses serial lane queues to reduce concurrency collisions, so two automations don't stomp on shared state. And it's intentionally capable. Sources describe file system operations, shell execution tools, and browser automation frameworks like Playwright. In the right deployment, that's leverage. Fewer manual runbooks, faster ops loops, cleaner internal workflows. In the wrong deployment, a single chat message can become a host-level incident. Transition. Real use cases. 3 pilots you can run without pretending you want full autonomy on day 1. Use case 1. Incident triage support for on-call. Problem. People burn time turning messy signals into a clean timeline and crisp next steps. Minimal stack. One connector into the gateway, read-only access to status data via model context protocol, and a skill that formats an update into your incident channel. Failure mode. Indirect prompt injection from a pasted log snippet, steering the agent towards secrets or unsafe actions. Mitigation. Keep it read-only, redact sensitive strings before memory is written, and require approvals on any outbound write beyond posting a summary. Use case 2. Internal developer operations helper, filing tickets, updating runbooks, summarizing pull requests. Problem. Admin work creates backlog drag. Minimal stack. a connector, an internal skills allow list, and tool policies that force approval for shell execution and file deletion. Failure mode, a skill that looks useful but quietly adds data exfiltration behavior. Mitigation, mirror and pin vetted skills. Review diffs like any dependency update, and don't pull directly from a public registry in production-like environments. Use case 3. Controlled browser automation for repetitive internal workflows, like pulling invoice PDFs from a vendor portal or verifying a software as a service admin setting. Problem: brittle manual steps and scattered credentials. Minimal stack: playwright in a locks-down environment, plus a narrow connector and a single-purpose skill. Failure mode: the agent clicks through a destructive admin flow. Mitigation: use test tenants first, allow list URLs and high-risk actions, and require approvals for any step that changes settings. Transition: why does this matter for builders now? Because OpenClaw pushes large language models from answering into operating. So your engineering decisions shift from prompt quality to systems thinking, identity, isolation, auditing, and safe by default execution. What differentiates OpenClaw from alternatives? Compared to wrapper libraries and orchestration frameworks, it's closer to an agent operating environment. A gateway, persistent memory, routing, and a skill system you can change without recompiling. Compared to bounded developer tools like a transient command line assistant, it's designed for continuous operation. That's the value, and that's the governance problem. Another differentiator that cuts both ways. Skills are often plain markdown instruction templates loaded at runtime, not plugins with strong per-skill isolation. So safety depends heavily on tool policies and approvals. If approvals get disabled for convenience, execution risk spikes fast. Transition: risks and limits. With mitigations, you can actually operationalize. Time-sensitive notes from early 2026. Reporting described high-severity common vulnerabilities and exposures, CVE, issues, including a one-click flow that could exfiltrate a stored gateway token and lead to gateway compromise, plus another CVE fixed slightly earlier. The engineering takeaway is stable even as details change. Run the newest patched release, and after upgrading, rotate gateway tokens and connector credentials as if they were exposed. There's also confirmed ecosystem compromise. Security coverage described malicious skills in the OpenClaw skill registry, referred to as ClawHub in reporting, including campaigns targeting crypto users. You don't need perfect counts to act. Malicious skills are a demonstrated risk class. Treat the skill supply chain like a package manager threat model, not a harmless marketplace. 3 more limits teams hit fast. 1. Secrets. If tokens are available to the runtime, assume a bad prompt, bad skill, or bad connector will try to reach them. Mitigation: least privileged credentials, short-lived tokens when possible, and separate identities per connector and environment. 2. Memory. File-based transcripts can retain sensitive data. Mitigation: redact before write, set retention limits, and treat memory directories as sensitive artifacts. 3. Reliability. Tool calls fail in messy ways: timeouts, rate limits, flaky portals. Mitigation: retries with backoff, idempotent actions, and human approval gates for anything irreversible. When not to use this. Don't run OpenClaw on a corporate laptop with broad credentials and casual port exposure, and don't expose the gateway or control interface directly to the public internet. If you can't isolate it and you can't patch it quickly, this is not the quarter to deploy it. Quick reset, deployed safely, what you get is a chat-native automation layer that can take real work off your team without handing every request a blank check. Transition. Here's a quarter-ready build plan. Step 1. Pick your capability tier. Tier 1 is read-only assistant mode. No shell, no file writes, and no outbound actions beyond posting summaries or opening pre-filled drafts for humans to approve. Tier 2 is action mode, but only for non-production scopes first, like a sandbox ticketing project or a test environment. Start conservative so your evaluation stays about automation, not incident response. Step 2. Patch and rotate like you mean it. Get to the newest patched release available, especially if you were anywhere near that early 2026 window. Then, rotate gateway tokens and connector credentials after the upgrade. Set a patch service level measured in days, not weeks, because this is an always-on automation runtime. Step 3. Isolate it like a remote admin box. Run under a dedicated, non-privileged operating system user. Keep it away from developer secure shell keys, production cluster configs, and broad cloud credentials. Prefer a hardened container or virtual machine boundary with minimal mounts. Add egress allow listing. Most skills should only talk to a small set of known domains, and log skill and tool invocations into an audit trail you will actually review. Step 4. Control skills like software supply chain. Maintain an internal allow list and mirror of approved skills. Pin versions, verify integrity, and block anything that downloads remote scripts at runtime. And remember that precedence order. Workspace skills can override others, so lock down write permissions and treat changes as code review events. Transition to the future. 3 horizons kept concrete. Near term, the next 1 to 2 quarters. Pilot read-only plus approvals automations for incident comms, documentation hygiene, and structured retrieval via Model Context Protocol. Opportunity. Faster internal loops with minimal blast radius. Dependency. Stable connectors and sane deployment templates. Blocker. Insecure defaults and weak secrets handling. Midterm, 6 to 12 months. Stronger registry governance, signing, provenance, and automated scanning becomes table stakes. Opportunity. Safer skill distribution and quicker revocation. Dependency. Ecosystem maturity and maintainer bandwidth. Blocker. Attackers keep targeting the skill supply chain because it scales across organizations. Longer term, 12 to 24 months. Expect hardened agent rind patterns, brokered manageable world in place. Brokered execution where the chat-facing agent doesn't hold the keys, and a separate action gateway performs side-effecting calls under strict policy. Opportunity. Autonomy without handing a single process the crown jewels. Dependency. Better isolation primitives and enterprise-grade secrets integration. Blocker. Convenience pressure will always push teams to disable guardrails, so winning designs make the safe path the easy path. Wrap back to the opening. OpenClaw can be your biggest productivity win, or a one-click compromise, because it's not passive. 3 takeaways. 1. Model quality is secondary. The primary risk is credentials plus execution plus supply chain. 2. Start read-only, then graduate to action mode with approvals, isolation, and egress controls. 3. Patch fast. Run the newest patched release you can, and rotate tokens after upgrading. That's the line between agentic automation and an incident generator.